Hope you guys are doing well. So continuing on our journey in OOP. Um, Today we'll try to learn about what composition is. What are the advantages of composition over uh, inheritance, and not the advantages. Like what is the need for composition, and then we'll see more information related to uh, that. Okay, so the first um okay, so let's start and understand why do we need composition in the first place. Now, object composition is a way of combining simple objects or data types into more complex ones. When we compose objects, we create objects that contain objects. Now, this relationship is known as a relationship. Now, object composition is a fundamental concept in OOP. It will be and a powerful tool for code organization and use. But designing our classes so that our objects will contain other objects, we are able to solve complex problems by composing simple and understandable parts. But what is object composition? Whenever a type has a field or a property whose type is a non-trivial type, then we refer to this as object composition. Okay, so let's try to understand this definition, like what is object composition more clearly, because just by reading text, let's understand why do we need object composition in the first place. Okay, so now so there is an OOP concept called as object composition, in which one object is made up of more than one uh, object. So by that, what is saying is, so this helps in contrast to it. Okay, and each object will have a specific role. So basically, what we are saying is, I have one object, and inside that, I have one more object. So this is one more object. So basically, one object is made up of more than one object, right? So you have one more over here. Oh no, what happened here? Let's move. Yeah, let's have. Basically, yeah. So basically, one object is made up of um more than one object. So you have one more object being present here, and so on and so forth. Now, what is the advantage of object composition over, like, what are we achieving here? I mean, what's the advantage of doing that? Okay, we'll see later on the advantages. First, we'll see what basically means. So remember, these are independent objects, right? So this is one object, and this is another object, and this is the bigger one. The key to understanding is it models. So So what does object composition is achieve is has a relationship. So object composition uh, leads to has a relationship. Okay. Now how to achieve this composition? How to have one object inside the another? So there are the two methods or two ways in which we can achieve. The first one is dependency, the dependency instantiation, instantiation, and the second way is dependency injection. So remember what is composition. To sum it up, composition is when you have one object inside the other. One object contains has more than one object inside it. So here you have more than one object inside it. So this is basically what is nothing but called as object. Uh, this is called as composition. Now, what does the term dependency mean? So then we said there are two methods, right? So like there is there are two ways in which you can achieve composition. One is dependency instantiation, another is dependency injection. So these are two words. So let's try to understand what is the dependency here and what are we trying to inject in here. The term object composition, however, refers to a specific type of dependency. Okay. Now, whenever the definition of a type uses another type, we say that first let's understand what dependency is. We say that the first type has a dependency on the second. So what I'm trying to say is, for example, a class is a type, right? So this is a class. So whenever we have a class, and then inside, so we said inside also we have objects, right? So even this will be an object of some class. So even this will be a class, right? Okay, so now what is happening here is, remember, for this class to be created, the outer one has to be first created, right? So you cannot bypass them. I mean, to access this object thing or to create an object from inside, we need to create an object of the another of the outer type. So this is nothing but dependency, right? That the inner one is dependent on the outer one. Or I can say the second class. So there is a dependency which exists over here. So this is nothing but what we call as dependency, right? Now the term object composition, however, refers to a specific type of dependency where a type has an instance variable of the other type. So composition, this is what do you mean by dependency. Now what he is saying in terms of composition. So what composition, according to composition, what is dependency is when you have um, when an instance variable has a specific type, right? Has Okay, so what he's saying is composition dependency is when my class will have an instance variable of the other type, right? So this is what do you is meant by a dependency, right? Not the In other words, well, whenever we have object composition, we have dependency. However, the inverse is not true. The difference between dependency instantiation and dependency injection is whether objects of that dependent class are instantiated by the class that depends on, or it's injected into it. But the benefits. Okay, so um, uh, I mean, there is some sort of dependency, right? When we have two classes inside one another. Now, why was composition developed? Like, now there is something called as coupling, right? Let's see what do you mean by coupling in OOP. So normal so before we go ahead, there is some more terms that we need to study, right? What do you mean by coupling? And then we will see what is loose coupling and what is high coupling. So coupling is basically we say um, so how dependent is one class on the other is nothing but what we call as coupling. So basically the ability to measure how the two classes are related to each other is nothing but called as coupling. So how this is related to other is what we say as coupling, right? I have two classes over here. Now when we say coupling, so remember when you do inheritance, right? uh, like when you do inheritance, now what you are going to do is you are going to inherit the properties of the parent, right? The child class will inherit the properties from the parent. So by that, what to mean we mean to say is the parent class or the child or this one which is present here, this is highly dependent. Like, I mean, these two are highly related, right? Because here when we create the child object, remember the parent methods are automatically loaded, right, in inheritance. So basically what we are trying to, if you try to make any changes in this code, right, this is going to affect all the classes which are here. Remember, we can have multiple inheritance, right? Java allows that, right? So I mean, so there are different types of inheritance. So the one that is allowed in Java is called as multiple inheritance. So what if you have another class? So I have another class, right? This is also inheriting from the parent, right? So this is going to inherit from the parent, right? This is the parent class. Now, if you make any changes over here, it will affect this child and this child as well. So this is nothing but we say that the child classes are highly dependent on parent classes, or we are having a tight coupling, right? Tight coupling is what is happening over here. These are tightly coupled, right? Whatever will, if there is any small thing which is changed there, it will directly affect the child classes. So this is nothing but in other terms called as tight coupling. So inheritance, by default will promote type coupling, right? But do we want our objects to be tightly coupled is the question that we are asking, right? No, we don't want, right? Whatever if whatever, like, I mean, we want to inherit methods, but it should not be that if we make any changes over here, it is directly going to affect both the child class. No, we don't want that to happen. So we want something called as loose coupling as possible to occur. So then we came to a concept called as composition, in which we said one object is made of more than one object. So you have the outer object. So this is the outer object, right? And then inside we have multiple objects being present. So I have, this is my object 1. Okay, let's have this is my object 1, and I have another object 2, right? Now so there is some sort of dependency, right? I mean, so that means to create an object in the now then you will say, sir, there is some sort of dependency that is existing here, right? Like if I have two classes and the instance variable of one class is going to refer to the instance variable of the other, right? So then what is the problem, right? Like, I mean, there is still some sort of dependency which is existing, right? So this in so suppose I have an outer object. So I have an let's say, let's take an example. So I have an outer object over here. So this is suppose my car class, and inside that I have something called as an engine, right? So this is my engine class, this is my car class, the outer one is the car. Now this engine class is going to get instantiated from here, right? From the parent class. So the parent class has to be first created, right? But remember what we have done here is, and if we have another class over here, we can again instantiate it and then so that will be called from the parent class, right? So what are we doing is, see, we are not inheriting any methods from the class to engine, right? Instead, what we are doing is we have somewhat reduced the amount of dependency, right? That means your methods, whatever are written, are independent of these two classes being called in. I mean, but in case of our inheritance, see, the problem that we are having here is there is a very high level of relationship, because the methods are going to be available in all the classes, right? So if I try to change one, and if I'm using it here, and if that has an effect, or that has some parameter that causes the which is present in the child class, which is being referred in the child class, everything goes out, right? But remember, dependency does so, even when I come in composition, there is some level of dependency, right? That means the outer class has to be created, only then we can have the inner. But now you see, the inner methods are no longer dependent on the outer class, right? There is no inheritance that is happening. It might be defined in its local scope, but there is not inheriting, right? That means if I try to change my methods here, those will not affect the class that I have what we say, that I have defined, right? I mean, this only thing that I need to add is the object creation from this, of the object creation of the child class, right? Yeah, the inner will still dependent. If you see, the inner classes are still dependent on the outer class. There is still some sort of dependency that is being occurred, right? But if you see the outer class, now outer class is not depending on the inner ones, right? You directly create this object. There is no linking of the outer with the inner. I mean, for the inner to exist, the outer has to exist. Remember, there is that issue which is still there. That is dependency is still there. But then there is no condition on the outer class, right? The outer class can exist independent of what the inner classes are. So what we have done here is we have made the outer class loosely coupled. However, there is some still some sort of tight coupling which is happening between the outer and the inner classes. So when we have objects inside an object, the outer object becomes loosely coupled because the dependency is not present, right? I mean, the outer class is independent, but when we see in terms of the inner class will become highly dependent on the outer. So is there any way in which we can make the inner one much less dependent on the outer or not? We'll see that. So basically, what has happened is we have made the outer class um, loosely coupled. Now, our goal is basically to make the inner class as well, or to reduce the amount of coupling in the inner class as well. Now, composition concept is when you have an object inside another object. For example, um that means we say, so the word composition is composed. So if you, this is like a verb form of the word composed. So this is a verb form. You can, this is a verb form. This is a verb form of This is a verb form of composed. So basically, what you are saying is the outer class is composed of many inner classes. So if you see the theoretical definition of composition is when you have when one object is made up of more than one object, then we say that the outer object is composed of several inner objects, right? So that is nothing but called as composition. Now, what does composition is achieve? Is first thing is it makes the outer class loosely coupled, right? So we have achieved loosely coupling for the outer class, but now our goal is to achieve loose coupling for the inner class, right? So this process where we instantiate our dependencies or the classes that are composed is called as dependency instantiation. So dependency instantiation is nothing but where the parent class will use its instance variables to create um the inner class objects. This is what we mean by dependency instantiation, right? This is nothing but composition. So since we are creating an object inside an object, it is composition. So one way is dependency instantiation, right? However, dependency instantiation still does not solve the problem of coupling, right? The inner class is still highly coupled, right? But still, the outer class is independent, but the inner one is still dependent. So now what we do is we need to create, however, we have gone down the level of coupling as compared to inheritance, but we still further need to reduce the coupling, right? For this, we do a problem called as dependency injection. So by dependency injection, we mean is so remember basically whenever you have a body, right, and when you try to inject anything from like when you use a syringe, right? So this injection word is what I'm trying to explain to you. What is do you may inject? So consider this as a human body, right? This is your assume that this is your this is the skin, and then this is the syringe which is outside, right? And it has some content. So what I'm doing is by creating a small hole, I'm trying to inject all these medicines inside the body from the injection, from the syringe. So hence we call this like this is as an injection because you are injecting from outside. In similar ways, the dependency injection has two meanings, right? I mean, two words. So if you say dependency, uh, it has it is made up of two words, right? So first is basically something to inject. Injection is something that is dealing with to inject. Now what are we injecting is the dependency. By mean what we say is you pass the reference of the what I'm see remember I have to create two objects, right? So what I do is in the class, instead of creating the object using the instance variable, you kind of pass in the object from outside. So this is nothing but what we call as dependency injection, right? You are kind of injecting it from outside. And remember, even in this, you are going to create objects, right? I mean, from both ends. Inside an class, you will be creating an object, right? So hence it is called as composition. So let's see how do we code how do we have dependency. First for let's see how to do composition, right? So let's have a class, say test1. Okay, so first let's see how to do composition. So we are doing composition using dependency instantiation. So let's have test1 dot java. Okay, you create up the main class has to be created, right? So I have a class test1. Then inside this, I'm going to have my public ps. Okay, public static void main is here. Okay, perfect. And then now I'm going to do create a class, right? So you come a class, and then I'm saying this is my class car. Okay, and then you are so the instance variable will be present in the construction, right? Constructor. So my constructor will have this. So I'm not going to do void. Let's make it public. Let's give it like a public access, and then I have a car. And then oh no, I'm referring. So then yeah, this is the constructor, right? Okay, and then I'm not having anything inside this. I have an instance variable. So this dot. Also, let's say uh, so yeah, let's have private variable, sorry, private instance variable attribute. Oh, I say, oh, let this be, yeah, private, and then type is string, and then I have name, right? And then I am calling. So now this dot name is going to be now I need to create a new okay, let's not have name. Let's say this is okay, now let's have our other class defined in. So remember it will be block scope, right? So I'm going to do class in class engine, and then this is my constructor, right? So this is so this let I have two variables in this class. So inside of the constructor I'm going to have the model and the name. So you kind of say this is what type of engine I'm having. So engine type, and then in the constructor of this, let's have that public, and then so I'm going to pass something here, and then I'm going to do this dot engine type is something. So I'll be having a string being passed in here, and that is going to be my you can say an engine type, also local variable. So let's assign engine type over here. So now when I come to my parent method, right? uh Now, so the parent constructor, what I'm saying is, you take in two values. One is the engine type, okay, and the model name. So I'm going to have a string here, then and then I have an engine engine. This is a local variable. Just okay. Let's have. So in name, is this is I guess this is in name. I'm going to assign model because model is being passed, and then I'm going to and okay. So let's have an instance variable called as string. So called as name, and then another instance variable which is now what I'm assigning here is okay, so that the other one has to be of the type engine, right? So because I'm going to assign it the reference, I'm going to create the object here. So and then I said this dot engine, and then here I'm going to do a new, then I have engine class being called in here, and then inside that I'm going to pass v8. So let's say this is v8. What's the issue now? Cannot. This is inside the inside. Oh yeah, I have one class. So this is okay. Oh, so I just need to create the object, right? So I have a mind writing the definition in here. Okay, yeah, you can have the definition outside. Let's make this class. So this definition is outside, and then what's so engine cannot be resolved to a type. So I have a class engine. Similarly, I have a class car. Oh, this has to be small e. This is not engine. Let's get rid of this. Is so this is going to create the object of this, and then for this all to work. So in our main, let's create the object of the parent. So let's have like a variable. No, class is car, right? So the type is car variable one equal to new. So first is you say model is, say suppose you say which is sports, and then you have another engine type that is being passed. So let's say that is V8. So my model is sports, and the engine type string is V8. So now instead of, so this is your engine type. So here instead of having engine, let's have the engine type string being passed here, and this is going to uh, create an object, right? Cannot expect where it is oh yeah, you need to end it over here. The engine cannot be converted to a type. Why is this? Oh, you define it before, so yeah. So now it knows that this is a class. Is this engi cannot be resolved to a type? Why? So this is class engine. Discuss the construct. Oh yeah, you need to have. Oh, let's have a colon here, and then this is my constructor of engine. I have an engine type. I'm assigning my reference to this. So instance variable of this engine type, and then here this has been kept private, right? I'm creating the object cannot be resolved to a type. So why is that happening? So my instead of main I have to have test one here. So I have this engine type, and then let's get rid of this cannot. So yeah, so this is there is no method, right? So now when I create a okay, Java C, it has to be right. So you do Java C test one dot, and then now when I try to run it, this is Java test one dot. I'm not. Am I doing anything like this is out? No. So this start method was kind of doing some printing maybe. Okay, so I have the start here. I need to call. This is again an inch. Now this engine has that reference, right? So can I use that reference to call? So what I can do here is inside this, let's have another method called as public void. This is basically a caller, right? And then here you basically do this. My current instance variable. Just need to call that. Oh no, this is going to get stored here, right? Oh, so now don't need that. I need to access the this dot engine dot start, right? I just need to I'm making sure that it's referring to the current instance. So when I run it, now this is going to call this start. So why isn't this printing? Wait. So my Clark has come here. I have test one as well? Have I created this? So when I pass in V8, so this is what is that dependency instantiation. This go to declaration or go to definition. This is that start, right? And then what is happening is this engine type is getting passed. Okay, I haven't called this caller right from outside. So you come here and do my car dot caller. So just call it from outside. I guess now it should. See, V8 engine is starting, right? So this is basically dependency injection. Now what it does is, so this is dependency instantiation. So basically, using the instance variable, I have created the object. So hence that instantiation word is coming into picture here. And the second way is you kind of do dependency injection, right? The dependent injection is a better. Now, see, we said that the inner class is still dependent on the outer, right? Now, what we do is in dependency inject, you kind of inject the dependency from outside. That means instead of creating the object inside, I'm just going to pass the reference from outside. So that is going to be that is basically what I'm going to achieve, right? So if I do a copy and I say control, let's do control A, control X, and this main has to be yeah. So by doing this, what are we achieving is where is my dependency? No, this is still instantiation. So you do control A, control X. Yeah, so now no, this is still instantiation that is coming. Now it should be working. Then there will be main which has to be test on. So you gotta see what I'm inject. This is basically a reference to the object, right? I'm passing that reference inside. So when I'm creating this car class, so what I'm doing is I'm externally creating the object of both the classes. So we have both of the classes being implemented outside. Objects are created outside. This is the object being created outside. And then what I do is in my car, I just pass the reference of that to this. So remember, both of them are creating outside, and then you just pass the reference in. So basically, what you have done is, even though the object is created inside, this is basically the object creation, right? And then so basically, I'm just going to inject my the reference to the object which is created to the of the inner class created outside. So it is dependency injection. A dependency is getting injected, right? Remember here again, both the class has multiple objects, right? Because this is basically a reference to the object, right? So you are again achieving composition over here. So that is basically what you mean by composition, right? Basically you kind of inject that dependency from outside. Now The $1 billion question that comes is, should we use dependency instantiation or when should we use dependency injection? Because composition can be achieved using both, right? Either you can so I mean both both ways you can achieve composition, right? So when to use what is the problem that we are facing right now. So we say when to use dependency injection or dependency instantiation, which to use and when to use. Like what should we go to, like when to use what. Now remember, dependency injection is used when you have very large scale applications, right? And you don't want a tight coupling to happen. Instead, you want them to be loosely coupled. So if loose coupling is our main goal or our thing that we are worried about, then yes, we should go for dependency injection. If we want to achieve, if the just want little bit to reduce the coupling, but the inner class still be coupled to the outer, then we say we go for dependency instantiation. Remember, both dependency injection and instantiation, in which basically you have objects inside objects. So both are nothing but composition, right? So composition is like a verb participle or a verb form of the word compose, right? So basically what you are saying is our outer object is composed of many inner objects. I guess that is all for composition. We also saw some little bit of code. In the next call, we'll start with interfaces and why do we need them, and we'll see. There is one more OOP feature that we want to see, which is extension. We'll see what is advantage of extension over inheritance. And yeah, so that is all for this lecture. I'll see you guys in the next one. Till that time, take care.